How was question 6? Had we done some of these? 6, 7, all good? 8, 9, we did? Girls, did you draw, you didn't have to draw tree diagrams for these if you didn't want to. For these? 10? Girls, question 11D, what they've said is correct. A normal coin is tossed and shows heads 8 times. Doesn't matter. Still, the probability that it shows heads next time is a half. That's true.
Where's that?
11D. That's still true. That's correct. What they've said is correct. Okay, so it said valid and invalid. Just see if there's something wrong with those. That's actually valid, what they've said in 11D. There's nothing wrong with it. All right? Now, question 12. What we'll do, I believe question 12B is a series problem, but we'll just look at question 12A, and we'll start to look at B, and then I'll show you why at the moment we can't do it. All right? So question 12. Exercise 7D, it was the homework. Now, we are going to be doing tree diagrams today. So it says, exercise 7D, question 12, it says one layer of tinting material on a window cuts out 1/5 of the sun's rays. So that means if it cuts out 1/5, what fraction of the sun's rays are still going through? 4/5, that's right. So one layer cuts out 1/5. There's still 4/5 going through. The second layer will cut out 1/5 of 4/5. So we've got, but they said using 2 layers. So the first layer cuts out 1/5, okay, of the rays. The second layer cuts out 1/5 of the 4/5 that's still going through, which is 4 out of 25. So therefore, the 2 layers cut out, don't they cut out 1/5 and then 4/25? Cut out 1/5 plus 4/25, which is 5 on 25 plus 4 on 25. It's 9 out of 25. We've got tinting material. We've got rays coming through. That tinting material cuts out 1/5 of the sun's rays. So 1/5, I suppose, bounces back. 4/5 goes through. Now that's one layer. Here comes the second layer. It'll cut out 1/5, but that was 1/5 of one whole. Now we're going to cut out 1/5 of 4/5. Do you get it? That's right. So 4/5 are going through. We cut out 1/5 of that 4/5 going through. Do you see what I'm saying? Okay, so 1/5 of 4/5 gets cut out. So 9 out of 25 gets cut out. That means, isn't that, no, it's not 9 out of 25. 4 out of 25 gets cut out. That means we're just seeing if it's series, and if it's series, you haven't learned how to do it, but I can give you the formula and we can just finish it off. So the first layer cuts out 1/5, so 4/5 goes through. The second layer cuts out 1/5 of 4/5, which is 4/25. So that means that the 2 layers so far cut out 1/5 and 4/25. Adding those together, 2 layers cut out 9/25, which means that 16/25 have still gone through. The third layer will cut out 1/5 times 16/25. 1/5 of that. What's going through? The third layer. Now that's 16 over 125. I don't think you can simplify that. Which is, that's what the third layer cuts out. So then you add that to what the other 2 are. So let's just look at how it's looking. So therefore the 3 layers cut out, now I'm going to do the series, 1/5 plus 4 25ths plus 16 over 125 so far. Now, let's just write that in terms of, isn't that 1 over 5 plus, isn't that 2 over 5? Wait, let's just see. No. I'm just having a look. To the n over r minus 1. We'll be learning that later. All right, now if you want, girls, this is a series. See how the first term is 1/5 and each next term is multiplied by 4/5? See, we start with 1/5, we times it by 4/5. Then this answer gets times by 4/5 again. And they get added. So this is the sum of a series. There is a formula, we haven't learnt it. Sum of a series, and we know that that sum, all of these, has to be greater than 9/10. So greater than 0.9, because 9/10 is 0.9. A stands for the first term. R is what you're multiplying each term by, and it's 4/5. So that 4/5 is just to the n over 1 minus 4/5. So that's got to be greater than 0.9. I know you haven't done this yet. Okay? So we've got 1/5, 1 minus 4/5 all to the power of n over, what's 1 minus 4/5? 1/5. What do you think happens with this 1/5 over 1/5? What happens if it was 2 over 2? Cancel, they cancel. So 1 minus 4/5 to the n is greater than 0.9. Actually, I wonder if we can just do it straight like that way. And that's what we're going to solve. So 1 minus 4/5 to the n is greater than 0.9. So can't I take that to the other side? 1 minus 0.9 is greater than 4/5 to the n. So taking that to the other side, isn't that 0.1 is greater than 4/5 to the n? And moving over. Now, do you know how to solve that? That 0.1 is greater than 0.8 to the n. Now you take logs of both sides. ln of 0.1 is greater than ln of 0.8 to the n. Now, doesn't that n come to the front with the log laws? So ln of 0.1 is greater than n ln 0.8. Now, logs of fractions less than 1 are negative. ln of 0.8 is negative. ln of 0.1 is negative. So when you want to work out n, you've got to flip the inequality sign around. Because ln 0.8 is negative. So therefore n will be greater than that. So does anyone have it? What's ln 0.1 over ln 0.8? Great. N's got to be greater than that. Therefore n is 11. So in other words, 11 layers. One set. A and B, it says, in a lottery, the probability of the jackpot being won in any draw is 1 over 60. Probability of jackpot, that's pretty good, is 1 out of 60. So therefore the probability of no jackpot would be 59 out of 60. Now it says, what is the probability that the jackpot prize will be won in each of 4 consecutive draws? How did you do that, girls?
1 over 60 to power 4.
I think so. Is 1 out of 60 times 1 out of 60 times 1 out of 60 times 1 out of 60, which is 1 out of 60 to the power of 4, which is something pretty.
Which is 1 over 129.
1 sec. 12, 9, 6. How many zeros?
4 zeros.
Okay. Okay, so it's pretty small. So how many consecutive draws are need to be made for there to be a greater than 98% chance that at least one jackpot prize, at least, isn't that at least 1 minus? 1 minus none.
1 minus 59 on 6.
To the power of n. That's right. Girls, how many consecutive draws need to be made for there to be a greater than 98% chance that at least one jackpot prize will have been won. They just want one. Okay, now, just one sec. Of at least one jackpot prize is 1 minus the probability that there are no jackpot prizes. Now, we don't know how many draws, so we're going to let the number of draws be n. So it's 1 minus 59 out of 60 to the power of n for n draws. We don't know how many draws. Like if it was for 2 draws, it'd be 1 minus 59 over 60 squared. If it's 3 draws, it'd be 1 minus 59 over 60 cubed. So how many consecutive draws need to be made for there to be a greater than 98% chance that at least means 1 minus none. Okay? And depending on n. So if n is 1, it means if we want one jackpot prize, wouldn't it be 1 minus 59 out of 60, which is 1 out of 60? Girls, tell me the probability of the jackpot being 1 in 2 draws. Couldn't you lose first time and then win? Win and then lose? So, and if you want at least one jackpot prize, you could lose and then win and then lose, or win twice. So, look, it would be for 2 draws, win, lose, win, lose, win, lose. We want everything except for lose, lose. If there were 2 draws, you would want everything. You'd want at least one means win, 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 lose, lose, win. So if there were 2 draws, we just want 1 minus lose, lose. Now that's 1 minus 59 over 60 squared. If there were 3 draws, I'd continue, and it would be 1 minus lose, lose, lose. And it would be 1 minus 59 on 60 cubed. Sorry. Because if you want to win at least one, it means you could lose all of them and win the last one. You could win the first one and lose all the rest. You could win 2. You could win 3. You could win 4. We just don't want all losing. At least one means 1 minus none. So if you want that to be greater than 98%, you make that greater than 0.98, because that's what 98% is. So it becomes 1 minus 59 over 60 to the power of n has to be greater than 0.98. So taking that to the other side in this one, 1 minus 0.98 is greater than 59 over 60 to the n. So what's 1 minus 0.98? 0.02 has to be greater than 59 over 60 to the n. Now we take logs of both sides. ln 0.02 needs to be greater than ln 59 over 60 to the n. What does the log law tell you about that n? It can come to the front, n ln 59 on 60. Now girls, logs of decimals less than 1 are negative. So therefore n has to be greater than ln 0.02 over ln 59 on 60. So therefore n is greater than whatever you get there.
232.755.
So therefore n is 233. Okay? Now, with the other one, I'm just wondering, rather than doing it by series, if we could have done it with this sort of tree diagram idea, because we did end up with... Because if you do ln of 59 on 60, it's negative. Log of anything less than 1 is negative. The reason I'm flipping here is if you work out ln 59 on 60, it'll be a negative number. You can work them out and then do it if you want. But ln of anything between 0 and 1 is negative. And that's why we flip. So n's got to be greater than 232.7, so it's 233. Ladies, question 17. So question 17, he's got 5 socks, 5 pairs in the drawer, right? So he's got 10 socks in the drawer. Okay, now I can do them in different colours if you want. 1. Someone pass me a blue. 2. I need 2 more colours. We got 3. Yeah, they do look like worms. Give me green, give me. Purple's good. And blue. 3. They all look the same colour. 4. All right, it's okay. They're socks. Shh. It's okay. You can sort of see them. Okay, stop. Shh. Okay. Nick has 5 different pairs of socks to last the week. They're scattered loose in his drawer. Each morning he gets up before light and chooses 2 socks at random. Find the probability that he wears a matching pair on the first morning. So girls, on the first morning, he'll pick out 1 pair of socks. See, that's not counted. Whatever he picks up, it doesn't matter. So he's picked up something. What's the chance now? So let's say he picked the purple. What's the chance now that he's going to pick the matching sock? That's right. So the probability that he wears matching on the first morning? No, it's not 1 out of 10. It's just 1 out of 9. Is that the answer, girls? Girls, it does not matter. They didn't say it has to have the purple ones. Once you've picked something out, it doesn't matter. It doesn't matter what you've picked out. What's important is the next thing he picks out. No, wait a sec. He probably doesn't even wash them. Okay? All right. So, girls, he picks the first one out. It doesn't matter which one he's picked because they just want matching. The chance that he's now going to pick the next one that matches is 9/10. That's A. Now, B. Find the probability that he wears a matching pair. Oh, sorry, yeah, 1 on 9. We said that, didn't we? There's 1 that he's looking for out of that 9. Now, find the probability that he wears a matching pair on the last morning. B and C for a minute. Let's go straight to D. Probability that he wears a matching pair on the first 2 mornings. It's 1 on 9 times. Well, there's 2. Yeah, because he picks up 1 pair. It doesn't matter which one. He's got a 1 in 9 chance that he'll pick up the same one. Then the next day he picks up a sock. It doesn't matter which one it is. And then there's 1 on 6. 7. Oh, yeah, because there's 10. And then there's 7 left that he could choose from. Okay? So 1 on 9 times 1 on 7 is 1 out of 63. All right. Yes, it is correct. Now, girls, the next one. Every morning, the probability that he wears a matching pair. First morning, we said it was 1 on 9. Now that 2 socks are gone and they paired up, then there's 8 socks left. He picks one, doesn't matter which one. There's a 1 in 7 chance that he will pick the same one. And then now there's 6 socks left. He picks one. He's now got a 1 in 5 chance. There's 4 socks left. He picks one. He's got a 1 in 3 chance. And it's certain that he'll now pick a matching pair. 1 out of 1. So this one is every morning. We've got 15 times 63. 630, 945. One out of 945. Yeah. So girls, probability the first 2 mornings, every morning. He wears a matching pair every morning but 1. So we've got a few different ways. He could have matching pairs on Monday, Tuesday, Wednesday, Thursday. No, you can't. If you have Monday, Tuesday, Wednesday, Thursday, Friday's automatic. So he'd have to not have the matching pair either on the first day, the second day, the third, or the fourth. Now, if he has matching pairs on the first, second, third, fourth, then it's automatic that the last pair is going to be matching. So if he doesn't have, so let's look at the first day. Girls, I think whatever you get, you're just going to times it. Anyway, first day, he picks out a sock, so he's not going to have a matching pair on the first day. Isn't that 8 chances out of 9? But, so, just coming back where we were before, if they match Monday, Tuesday, Wednesday, Thursday, then it's certain that they will match on the last day. So you can't have 4 days of matching and then the last day it won't. Because if you've got 4 days matching, then the other day has to match. That should be really every morning but 2 would be possible. Okay? But not every morning but 1. Because if it's matched 4 times, 4 pairs are matching, doesn't it automatically hold that the last pair will match? So and it was going to be a really difficult thing to do. The thing was going to be really complicated. Anyway, but you see, we realised that it wouldn't work if you're going 1, 2, 3, 4, but it won't work for all the others anyway, because if it matches 4 times, the other one has to match. So it's impossible, 0. So girls, for B and C, I think you're just looking at those probabilities without even regarding the other days, I think. All right, so it's 1/9, 1/9. In other words, the probability that it matches any day is 1/9. But it seems a bit strange. And A are 2 of 12 guests at a party. And they're playing doubles on 3 courts. The 12 have been divided randomly into 3 groups of 4. Find the probability that K and A are on the same court. Let's just put K on any court. Doesn't matter. So let's say K is here. Well, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots left. For them to play on the same court, there is 3 out of 11 chances. There are 3 out of 11 chances. Because if K is, for example, it doesn't matter which one K is on. Doesn't matter. There are 3 spots left here out of 11 players still to be allocated a court left. And they just want them to be on the same court. Okay? K and A both play on River Court. Now that's a specific court. So what's the chance? Let's call this one River. It doesn't matter. Well, girls, isn't it? K and A on River. So girls, first we've got to choose the court. 1/3 of a chance that the first person will even be there. Times, I think it's times 3 on 11 that they're together. It's 1 out of 11? Yeah. So girls, the chance that they're on the same court is 3 out of 11. And the chance that they're together on one specific court is 1 out of 3. So it's 3 over 11 times 1/3. So they're together, and the chance that they're on a specific one, I'll call that one River, it doesn't matter, or this one River, since I put him there in the first place. So it's 1 out of 11. Now, C. The probability that K is on River and A is on Rose. All right. So I'll label the courts. River, Rose, doesn't matter where they are. Probability that K is on River. Isn't it 1/3? Will be on River, it's a 1 in 3 chance. Now, the chance that A will be on Rose, 1 in 3 chance that K gets in there, a 1 in 3 chance that A gets on Rose, but then Rose there's a 4 in it because they're randomly placed. There is a 4 out of 11 chance that Rose ends up there. Because there'll be 4 people out of 11 there, and Rose is one of those 4 out of 11. Well, so the 3rd is for K, and there'll be 4 people on Rose Court, and he's got 4 chances out of 11 to be that person. If K has to be on River Court, that's 4 chances out of 12. And if Rose then has to be, that's 4 chances out of 11. So doing the 1 out of 3 here as well, that's the chance that he'll beat K and A on River. K's got 4 out of 12 chances. That one's got 3 out of 11. Yeah, that's easier.